Hello, fellow educators. This presentation will provide you with an overview of the tools and technology to teach an interactive lesson using multimedia tools. This lesson can be presented to a group of students in grades 4th through 7th as a one-day introductory activity to familiarize learners with meteorites. They will be viewing actual samples that they can interact with along with a class activity to simulate how craters are formed when one object collides with another. Since this is not a unit, it is designed to be a one-time school visitation presentation that offers students an opportunity to observe meteorites up close and personal. The object of this activity is to give students an opportunity to compare and contrast the visual differences of objects older than Earth, and to create their own evaluations of how meteorites help scientists study the universe. This activity is designed to help the student visualize what happens to the moon and other celestial bodies when a large object from space hits their surface. They will work in small teams of 3 to 5 students depending on group size. Everyone will be given an opportunity to drop an object into the layered sand to observe and measure what size crater was created. Then they will discuss how this would affect the surface and what kind of damage it may cause. These are samples of the activity. Colored sand is used and sprinkled in layers to clearly illustrate what occurs when impact is made. Students will learn the components of the universe, including stars, nebula, and galaxies. They will learn to recognize the Sun as a medium-sized star near the proximity of Earth. Included in the presentation is a visual of where the asteroid belt is found in space. Star objectives antiques are shown here. Students will compare and contrast the different types of meteorites and develop a working understanding of how they came to Earth. Finally, they will explore and evaluate how an impact crater is formed and how they may appear on an object they have collided with. This lesson is based on the constructivist theory of Velikovsky's zone of proximal development using Gagne's 9-event model with some modifications. It is an inquiry-based discussion using PowerPoint, screen-captured video, and activity-based simulation. I used a modified Gagne model because it best represented what was done. I seldom see the same group of children, so I need to make sure that what they are presented lasts and make a memorable impression. For that purpose, I have created several lessons that can be used for 2nd to 12th grade students. They are all easily available using the free version of online tools and commonly used applications such as PowerPoint. I can create a virtual tour of the moon's surface or walk inside a crater on Earth. The technology used to create this lesson is Snagit, Nearpod Web 2.0 app, PowerPoint presentation, computer, smart screen, and Chromebooks or iPads. Snagit is a tool that has many advantages. It has a small fee, but you can get the educator's discount, and it is so worth it. You can capture any graphics, and you can't beat the tagging features and word bubbles. Thumbnail images can be made for your blog or web pages. I have used Snagit for more than 4 years, and the upgraded version is even better. I can make videos of presentations and capture pictures that can easily be resized to fit any place I need them. I also can record just about any event I want to show the students and then place it in a PowerPoint. You can capture screens as you view webinars, which can cut down on note-taking. You can use it to provide feedback and comments to any written document. You can watermark a document to reduce plagiarism. With the PowerPoint presentation, I can add animations to the presentation and put timers in the question portions so that students can be timed. Emphasis can be made by pointing out key information, by making the objects move, or by adding drop-in comment bubbles and arrows. Because the presentations are controlled by me, I have enough time for the students to thoroughly view the objects being passed around the classroom. The Nearpod application offers multiple assessment tools and is cloud-based, so as long as you can connect to the internet, you can get to your content. Nearpod adds an interactive component to your lessons. It can be accessed on any mobile device that can connect to the internet. Using Nearpod, you can upload existing PowerPoints that you have already created, and it allows you to add web content, videos, quizzes, surveys, short answer questions, and filling in the blanks. Here we see how Nearpod is a great tool for checking student understanding as the presentation moves along. Using Nearpod and Chromebooks fit well into an outreach program where you have to carry all the supplies that are needed everywhere you go. These were the key reasons for choosing this device and method of presentation. Once students are shown how to use the Chromebooks and how to access Nearpod program, they can work in teams, which means I don't need many Chromebooks. They are given an access code that allows them to be able to log into a specified lesson to answer the mini quiz questions, which is easy and fun to use. These methods serve a traveling teacher well because I have no way of knowing what tools or equipment will be available on site. The tools chosen facilitate the ease of movement. Using these devices and programs help to relieve the stress of lugging around pounds of paper. I have at least 5 different activities that are based on different levels of computer skills depending upon student age and abilities. I do work with special needs groups as well as ESLs. Since my range of student impact is so broad, I need to make sure the tools I use meet that need. Thank you for viewing my presentation.